All right, everyone. Thank you for joining my session today, where I'm going to be talking about continuous performance testing in DevOps. I'll give you a quick intro of myself before we dive in. Please feel free to put any questions in the chat, and I'd be happy to get back to them after the talk is over. We should have a bit of time. So I'm Lee Barnes, CTO of Utopia Solutions, and my focus over the past 25 years or so has been primarily on performance testing and test automation. And more recently, I've been focused on helping organizations implement those activities within their Agile and DevOps delivery cycles. So let's jump right in. This may come as a shock to those of us that fancy ourselves as performance test engineers, but I want to say that performance testing is dead. And hopefully now that I have your attention, let me qualify that statement and say that traditional performance testing is dead, at least in Agile and DevOps environments. And to understand why I might make such a potentially controversial statement, let's take a look at what traditional performance test generally looks like. So it was certainly born out of the waterfall model, where a single cycle stretched out over many months or sometimes many years. And then after functional testing was completed, we developed and executed a large-scale system-level performance test. And that typically lasted many weeks. And I spent a good portion of my career helping organizations set up centers of excellence that became very effective at executing this type of performance tests. And that involved enforcing the often very strict rules that went along with it. So if you want to test our app, it must be functionally complete, because if you can't prove that it works in at least a single user environment, how can I possibly test it under a multi-user load? And for the entire time that we're working, consisting of test planning, script development, execution, you better not change the code, because I might have to start over. And of course, if you want your results to mean anything, you're going to have to give me a production-like environment. So let's say we do that, and what happens if we find issues, right? If we have performance issues after we've completed development of the system, or even just a feature in some cases, our options aren't good, right? We either delay the release, which means that we're delaying delivering that value to our customers, or we get hit by what I call is the freight train. And that freight train is really lost revenue, lost brand value, lost customer loyalty. And it's also, of course, the cost of increased remediation compared to if those issues were identified and addressed much more early in the delivery cycle. But either way, I think we can probably all agree that our options aren't very good. So let's look at maybe another approach that I've seen a lot of organizations take, and that is trying to execute traditional style performance testing at the end of each development sprint. And at first glance, this might seem like a logical approach, right? The thought being that if I start relatively early and build small, maintainable performance tests, that I might be able to keep up as I build my application. But of course, the reality is that there's really no way that we can follow the rules of the traditional performance test if we're taking an agile approach to software delivery. If we wait until new features are functionally complete and tested, there's really not time to enhance and maintain that performance test suite. And we certainly aren't going to freeze the code for an entire sprint, or worse, multiple sprints, while we develop and execute that performance test. And we probably don't have, at least when we're early in the process, have anything that resembles a production environment. So we end up combining these short agile development cycles with lengthy, rigid performance tests, and we end up with a disaster. And so what we appear to be searching for here is more of continuous feedback on performance rather than getting this one big bang style test and feedback at the end. So if what we're searching for is continuous performance, what is that really? And maybe it's better to start with what it isn't. It's not just more frequent performance tests. It's not just moving performance testing to earlier in the cycle. And it's certainly not just faster or completely automated performance tests. But it is an appropriate level of evaluation of performance at each stage of the delivery cycle. It's more frequent, visible feedback on performance. And an important aspect of that is trending that feedback across your builds. You create really a continuum of performance data as you develop your application. So if traditional performance testing doesn't work in DevOps, but there's certainly a lot of organizations that are building software with that approach and being successful at it, let's take a look at how they're doing with respect to performance testing. And according to the 2019 State of DevOps report, not very well, right? Even if we look at elite DevOps performers, only 28% of them have automated performance tests. And if we read between the lines a bit, given that most performance tests are in fact automated, we can infer that maybe only 28% are doing performance testing at all. The report isn't very specific on what it talks about, but I think we could probably all agree that there's a lot of room for improvement here. So if even the elite performers are lagging in terms of performance testing analysis, there's got to be something standing in the way. And in my experience, there's a handful of things. So let's take a look at some of the more common obstacles with respect to building performance testing analysis into your pipelines. First is the lack of performance-related requirements in user stories or at all, for that matter. If we're not thinking about performance from the beginning, it's difficult and probably unfair to expect the team to think about it as features begin to move through the development cycle. Similarly, development teams often lack the knowledge and experience for performance analysis and testing. And this is especially true in organizations where that was handled by an outside team in the past. And similar to that, the development teams don't have accountability for performance testing and analysis. And again, especially where that traditional style performance testing was handled by someone else. And finally, the concept of performance analysis was limited to, again, running those large-scale system-level performance tests. And the organization as a whole really doesn't possess the skills or the tools required to analyze performance at a much earlier or much lower level. So let's start to look at those obstacles a little bit. And one of the huge holes that I see in organizations is the failure to think about performance from the beginning. And this hole was created many times in software development processes where understanding the performance of the system, again, was always someone else's responsibility. But just a big of concern as having that gap is making them lazy when it comes to performance, right? Again, always someone else's problem. So no one else besides that performance test team really needs to think about performance. So a good way to address that is to start thinking about performance factors when you build your stories. So for example, let's think about performance factors related to this story that describes the ability of a dealer of farm equipment to create quotes in the field. Maybe I know that we have a peak of around 1,200 concurrent users from our historical application data. And given that we are literally going to be out in the field, we're going to have varying network conditions that we're going to have to deal with. And then we know just from user expectations, that we don't want average screen-to-screen response time to be anything greater than 2 seconds. I don't recommend spending a lot of time on this early, right? We're just trying to get awareness of potential performance factors out for the organization to see from the beginning. So we don't take that traditional approach of waiting for that performance test engineer to worry about it at the end of the cycle. So thinking about performance factors is a good first step, but how can we incorporate that more formally in our requirements as we start to firm up those stories and start to do our work? And I've seen a handful of approaches, and really I think what's right is depends a bit on how your organization prefers to work. So let's look at some examples that you might be able to use. One of the more popular approaches is to include performance requirements as constraints that certain or maybe even all stories need to meet. And so if you think about performance requirements, things like response time, support for a number of concurrent users, or some support for some throughput volume, they often apply to many user stories. So as we create the user stories, we can link their acceptance criteria as appropriate, of course, to these existing constraints. We also may have performance requirements that are specific to a story. It may make sense to include them directly in the acceptance criteria of that specific story. But we need to be aware that user level performance criteria likely is something that only can be tested at the system level in a production environment. So in this example here, I'm not going to get meaningful results for high concurrency, high throughput tests in an environment that isn't sized appropriately. And before I move on, I want to say that how you approach incorporating these performance requirements, again, really should fit the way your organization prefers to work. The key is to begin to develop that awareness of performance. And I think the method by which you do that is less important. Again, right, if we're talking about DevOps, a continuous improvement culture is very important. So start with what seems to make sense for your group, expand what works, and of course, pivot away from what doesn't. So another common thing that's missing for us to be able to incorporate performance testing and analysis in our pipelines is accountability. And again, it's not surprising that we see a lack of accountability very often. There's still a lot of inertia around that traditional performance testing when it was always someone else's responsibility. Responsibility. We just talked about awareness, and I believe awareness is an important prerequisite to accountability. If teams aren't aware of what we're trying to accomplish, how can we hold them accountable? And as we just discussed, two important ways are to build that awareness, or to discuss performance factors early, and then incorporate those performance-related requirements more formally in your stories. But we also need visibility. Awareness is one thing, but if we're not constantly reminded of how important performance is, we're likely going to let that slip into the background. So, and I found the best way to keep performance visible is to ensure that our definition of done requires us to document those performance factors and performance-related acceptance criteria as part of our stories. I've also seen some organizations create the role of performance owner. One organization even called performance czar. It's important to note, though, the responsibility of that role is not to own all things performance, but rather to ensure the teams are adopting a culture of performance accountability. The role is responsible for really clearing the way for performance by providing the guidance and ensuring that the team has what it needs to build in performance testing and analysis throughout the delivery cycle. So again, accountability is good, but we can't expect the teams are going to magically have the skills and tools to implement performance-related processes into the delivery cycle. You have to start building that expertise, and I would suggest one team at a time. If you're part of an organization that has or has had a performance testing center of excellence, you can bring those experts into your teams and start seeding them with expertise that way. Once a team begins to become self-sustainable, you then can begin to expand that out to other delivery teams. In parallel, it's a good idea to develop a virtual COE that can provide guidance and oversight for performance related activities. I'm not talking about heavy process or oversight, but a virtual community that can work together and share ideas, lessons learned to ensure that continued improvement and growth in this area. Also need to think about bringing the appropriate tooling into some upstream environments, not just load generation tools, which may already be there, but also performance monitoring diagnostics that can help you understand more than just user level performance metrics. So once you start implementing these factors, you can start to see the shift from this centralized responsibility of performance or an external responsibility of performance to something that's more integrated within your delivery teams. And that's when you can really start to accelerate this process and see the value of that continuum of performance data. So let's start taking a look at how we might go about this. And I think a good way to do that is take a look at our pipelines and consider what we can learn about performance at each stage. So I've laid out a relatively straightforward pipeline here to help us with that discussion. So of course, we can learn something about performance at the performance and load stage. And this is where we're likely going to execute something that looks more like a traditional test. But as we'll discuss, we won't have to do it on every build. Certainly learn something about performance at the integration stage. This is going to be focused test on individual components or smaller groups of components, things that we can execute very quickly and have few dependencies, or at least have the dependencies mocked. Also discuss how we can learn about performance in production, and not just from a traditional monitoring, but using other techniques as well. And finally, we might even be able to learn something about performance when the code is committed, depending on what we're doing. The key is to evolve to a state of regularly evaluating performance, so it becomes easier to track performance regressions to the commit where they were introduced. The old traditional way of performance testing much less frequently really leaves many possible culprits that require a long investigation. So over the next few slides, we'll take a look at each of these stages in a bit more detail. So let's start at the beginning of the pipeline and see what we can learn about performance at the commit stage. And I'm talking really about unit level performance testing, and there are some organizations that are practicing that. There's even some tools and some libraries that are purpose-built for unit performance testing. The table here is something I gleaned from a somewhat recent research paper out of Charles University in Prague, and it lists the most popular unit test frameworks. But popular is certainly a relative term here. This study reviewed almost 100,000 Java-based projects in GitHub and found only that about 3% of them had some form of performance unit testing at all. So of those frameworks and tools I listed there, just for your information, JMH was the most popular. About 72% of them use JMH to help with their performance level unit testing. Certainly not every method in every class warrants performance testing, right? But there's definitely a benefit to testing performance at the unit level where appropriate. And these should be true unit tests, right? You've mocked out the dependencies. You're just running them with multiple threads or multiple iterations. It should be understood, though, that running them as part of the build process can be problematic because you just don't want other things going on in the environment to impact those results. But frameworks like JMH actually can help you package up your tests and run them on an isolated environment to give you more confidence in your results. Certainly some important considerations here for including performance unit testing. Probably the two of the most important are controlling the length of these tests, right? We don't want these tests to run too long because we want fast feedback. But at the same time, at the unit level, variations in performance might require a long-running test just to get enough data to have a confidence level in it. So what you trade off there is for those shorter tests is you're only going to identify probably larger performance issues, which at this level I think is fine. And of course, the absolute value of these results at the unit level in terms of response time and other things are less important. It's more important to trend those results across builds and look for commits that depart from those trends. So moving down the pipeline, we can definitely learn about performance at the integration stage. This is after we've checked in code, we've run our unit test, and now our CI server is deploying our build into an integration environment. So what does that look like? Again, it's tests focused on individual components, probably the most critical components, certainly at first, if we're just getting started. We can always scale that out once we gain some experience and worked out the kinks in this process. Again, we're still pretty early on in our pipeline, so we want fast feedback, right? That's an important part of DevOps. So these are tests that include individual calls. They're executed by a small number of threads over a small number of iterations, right? We're not trying to execute real life load at this point. We want to limit the complexity of our test setup, so we want to mock any dependencies that the component might have. We also think about measuring not just response times, but also some system level metrics by extending some of our APM tooling into the delivery cycle at this point. Again, some important things to consider, right? We don't want to, or we want to execute our tests on every build that gets deployed here. But similar to unit performance testing, those results aren't necessarily deterministic. So we probably shouldn't have the tests break the build. We're more trying to gather the information that we can analyze. Finally, it's important to understand that we're not looking, again, for absolute results here, right? We want to trend those results over time across builds. We're not trying to answer questions about how the system is going to perform in production, right? We're just trying to identify performance issues that may have been recently introduced. I should say probably at this stage, right, that don't go back and try to recreate this immediately in your environment, not because it's necessarily difficult, but more because you want to build this in a way that's sustainable and provides value to your organization. Most organizations start very small, right, with a single component test, maybe even triggered manually at first, and then they start to, and we'll talk about the approach a little bit later, but then start to scale that out a little bit. So before we move on along those lines, I want to dive in here a little bit. We just talked about testing performance at unit component level, but really let's not kid ourselves, right? That for many applications, that's much easier said than done. For microservice-based architectures, it's more intuitive, certainly at the component level to design tests. Each component is relatively focused in its scope and identifying its dependencies for the purposes of understanding mocking or service virtualization is much more straightforward. And they lend themselves fairly nicely to short focused tests that can be run very efficiently. However, right, many of us still deal with monolithic architectures, and the idea of a component is a little bit fuzzy there. So the ability to execute these nice, neat little tests that focus on specific component becomes more difficult. So while you may not be able to accomplish the same level of compartmentalization as you could with more of a service-based architecture, there's still some things that can be done. And I think a good place to start is to map specific user actions or to areas of interest within that application. This might be a specific process or business logic area of the application, might be a specific stored procedure at the database level. So rather than thinking about testing from the user perspective, think about areas within the application that may have performance issues, either based on your knowledge of the system or historical data. And then identify the user actions that exercise those areas. Again, might be a little bit easier said than done, but you want to create scripts that are as focused as possible, right? Again, not end to end across the entire application, but just enough to hit the areas that you're interested in. And again, for monoliths, the scope of that performance testing you can do earlier in the cycle, it may be limited. The tests are likely to be a bit longer. They're likely to have more dependencies, and therefore the effort to maintain them might be greater. And of course, the ability to mock dependencies and data might be limited as well, or at least require more setup time. So let's move on to the acceptance stage. It's certainly common to have an inline environment, and this might be where you're running your functional regression test or UAT test. But you can also run additional component level tests here, or small subsystems of components. Also, an out-of-line environment. And this is where you'd be running more traditional style performance test. So for the inline environment, there's actually some things you can do to your functional automated tests to capture performance metrics as part of those executions. Typically, we'll capture response times, user and browser level performance metrics, maybe even HAR files by using something like browser mob proxy. This data can be saved off as part of your execution results and then analyzed later. Again, we're going to be executing component level tests on every deployment, dependencies mocked ideally. But for the out-of-line system level performance tests, you're going to execute them hopefully much less frequently, depending on what you're doing in your release cycle. The key here is that you're evaluating performance continuously throughout the delivery cycle, right? And this traditional level test is more of a confirmation of what you already know versus the first time you're learning about performance of the system. I should mention that all the recommended performance practices apply here, right? There's no magic. You still need to make sure your load profile, the number of users, what they're doing, appropriate throughput, et cetera, is understood. You understand the test data requirements, you've prepared accordingly for those, and you're monitoring not only user level metrics, but system level and application level metrics as well. So before we talk about moving on and testing in production, I want to give you a conceptual view of what the overall process looks like, and maybe some representative technologies that can be used to put this all together. I've listed some tools here, as you'll see. These are just examples; they're not recommendations. Just to give you an idea of what the tooling looks like throughout this process. So first we'll start out with whatever we're testing, right? The system under test, and we're going to need some tool to generate load and throughput. And we'll want more than user level metrics, which of course our performance test tool or load test tool will give us. So putting some APM level tooling in the early stage environments is important as well. We'll want want to collect the results, both the load level results and from the APM tools, and ideally store them in some type of time series database. Then we'll need a mechanism to alert the appropriate people, right, that tests have completed or if any anomalies were detected. And of course, we'll want to make these results available to anyone that needs to see them. And finally, we'll want this process as automated as possible. You might be thinking that this seems like a lot of work, and how can you possibly carve off the time with everything else that you have in your backlog? And you're right, this is not a trivial amount of work, but you don't need to build this overnight either. A good place to start, again, is executing a few simple component tests automatically as part of your build deployment. Then maybe getting an APM solution running and getting those results collected, and finally adding the capability to collect them and broadcast the results. And speaking of the backlog, right, this should be part of your technical backlog, so it becomes part of the efforts towards continuous improvement, right? If this work and effort is off the books, right, it's not documented anywhere, it's not in anyone's backlog, it likely is never going to be done, right? So we need to manage this in the same way that we manage all our work. So that was a lot of information in a relatively short period of time, but I think it paints a good picture of what continuous performance can look like and the value that it adds. But before we talk about a couple of miscellaneous topics and wrap up, I think it's good to talk about some of the realities of implementing this before we just all go back and try to do this ourselves. First, I recommend that you start small. All right, and a good place to start, again, is running some component level tests against a few of your more critical components. Get comfortable with that process and the tools that it takes to execute those tests, and how you get that information to your team in a consumable, actionable state work out the kinks, and then scale to other components and other teams, and eventually to other stages of the delivery cycle. And as I mentioned, this should not be off the books work. Make implementation part of your technical backlog. Probably the biggest issue that I see in this is information overload. And so part of getting comfortable with this process is not overwhelming your team. This is information that the team likely hasn't received before, at least not with any regularity. So you need to prepare them so they're not only ready to consume it, but they understand it and can take action on it. Much of the value of performance testing is in the analysis, right? We can't assume that our teams possess the ability to understand that data you're giving them and take action on it, right? This is going to be a learning process. And also, successful performance testing activities aren't just implementing tools, right? You need to make sure that you take care of the supporting factors and that we don't have unlimited time to execute tests. So you need to think critically about which tests are important. If these tests are going to be executed as part of your delivery cycle, they're likely going to be run on demand. So what do we need to do from an environment and a test data perspective to enable that? This will not be a fire and forget solution. As you implement continuous performance testing, you should continuously get feedback from the team so you can improve the solution, right? And make sure it's adding the appropriate value. As ability to understand the information that you're giving them and they can begin to take action on it evolves, the team's going to be able to provide valuable feedback on what other information they need and how they need to get it. And don't do this in a vacuum, right? Everything that is being implemented should be out in the open, right? To just ensure that you make it, again, part of your backlog and part of your continuous improvement efforts. So let's move on to talk about performance in production. I think most of us are probably monitoring our applications in production, at least we should be. However, testing in production once was taboo, right? No one talked about it, much less did it. But it's certainly fairly common today, and it's really an important part of a continuous performance strategy. So, from a testing perspective, the obvious benefit is to confirmation that production can support some of your expected load conditions, but it also allows us to test the entire system, not just what's behind the firewall or what's reconstructed in a lab. And with the wide availability of cloud-based load test tools, we can evaluate the user experience from various locations and around the world, as well as various network conditions. We can combine testing and monitoring that gives us specific data we want by executing synthetic transactions in production. Similarly, we should create a continuous feedback loop between the upstream testing and the monitoring we do in production. This is going to improve both your test design from a performance testing perspective and your monitoring configuration. Of course, testing in production isn't as easy as pointing your tests to the prod environment. There are some things we need to do to maximize the benefit and minimize the risk. And one mistake that I see, especially from the performance testing side, is creating that strategy in a vacuum. You need to get input from across the organization so you can put together a comprehensive plan that's safe and is going to add value. Certainly, if your app is hosted in a third-party environment, you're probably going to need to coordinate with them. If you don't, you risk making them very unhappy at minimum, or being blocked because they think it's some type of denial of service attack. Of course, if your app is already live, you have customers, and you need to either find execution windows that minimizes the impact on those customers, or you can possibly cordon off part of the environment to handle the customer traffic while the test is run on the remaining environment. The system should know what's being tested, right? After all, we're in production, and we can really screw up the business depending on what type of application is and what you're trying to accomplish. And this is really another reason to have broad input from the organization, right? If the system is architected from the beginning, or at least adapted over time to understand that it's being tested in production, this all becomes a lot easier. Probably a good idea to eliminate or mock out requests to third-party services, right? We don't want to unintentionally impact their customers as part of your testing efforts. So before we wrap up, there's a couple key points that I'd like you all to take away. Probably most importantly is that the traditional end of cycle performance tests that we've been doing as part of longer release cycles, they just don't jive with agile DevOps and agile and DevOps delivery cycles, right? The rigid rules, strict rules that we have to follow, the lengthy time for setup and execution just does not fit in faster delivery cycles. Also, again, right, it is not just faster or more frequent performance tests, right? Especially faster, more frequent traditional style performance tests, right? What it is learning about performance continuously as appropriate throughout the different stages of your pipeline. And again, we can learn about performance at every stage of our pipeline, even the commit stage, if that makes sense with your application. And then finally, and probably most importantly, start small, right? Again, the process I laid out here is something that many organizations develop over a relatively lengthy period of time. And what that ends up looking like in each organization depends very heavily on how they work and how they're organized. So start small, get feedback in terms of the information, what value it's providing, what isn't valuable, the speed of the feedback, and continuously improve. All right, I'm always happy to talk about this stuff, so please feel free to reach out to me at any of those methods there. Happy to answer any questions that might come up down the road. And of course, we have a few minutes here right now if you have any questions that you want to ask. So I'll hang around for a few minutes, and also feel free to direct any questions to me in the chat as well. Thank you. And of course, thank you to the conference for having me, and hope everyone's enjoying the day. Thanks. So we do have a question. I will answer it in the chat as well, but since we still have a few people on, I'll answer it live. The question was regarding performance testing in production is, for production purpose, isn't it better to develop some KPIs that will monitor instead? So I've heard certainly from some people argue that, if you had sufficient monitoring, performance testing wouldn't even be required. I've even had maybe a more ridiculous argument, or I've heard one where if you did enough testing, you wouldn't need to monitor. I think they go hand in hand though. So certainly getting your monitoring strategy in terms of what you want to learn about the application in production is important. But with performance testing in production, you're not necessarily executing the happy path transactions that your customers are going to to execute anyway. You can run synthetic transactions to do things that maybe are critical to the application, but you can't necessarily guarantee that your customers are going to do. Also, you can use synthetic transactions as an early indicator of issues. So it will help you understand potentially performance issues or other types of issues that your customers will see but haven't seen yet, or at least they haven't seen at large scale. So you can identify issues a little bit earlier and potentially address them in a more graceful manner than having a large majority of your customers run into it and start reporting that now we've got a production issue. The earlier you identify those issues via the synthetic transactions, the earlier you can, or the more probability that you can head off, severe impact or outages. So good question, and I'll put this in here in the chat as well, but thank you. Another question that just popped up. I've only got a minute left, but it's what's your suggested approach with introducing performance tests in organizations if there are no performance tests, but some otherwise advanced DevOps processes? So just briefly, and I can put this in the chat as well, and you can come back later, but just briefly, the fact that the process is there is good, right? You can insert the performance testing actions in those processes. Typically, I would start with component level integration tests. So if you're deploying automatically to an integration environment, set up some performance level test on those, on individual components. These would be, small tests, a small number of concurrent threads, a small number of iterations, maybe 10, 50 iterations to get enough data so you can get the some statistically significant data, and save those results off and trend them over time. So each build that goes into that environment runs those tests and generates the data. If they're API level tests, they should be pretty pretty easy to maintain, versus certainly UI or HTTP level tests. But if they're API calls, they're typically pretty easy to create and maintain. But I would start at that level and start to get that data, feed that data back to the team, find out how important it is to them, and then expand out to other components, and then maybe a little bit further down the pipeline, start to maybe run tests at the subsystem level. But typically the integration stage and component level is where most organizations start. So thank you for that. All right, my time is up. I'm going to sign off. Again, please feel free to reach out to me at any of these means if any more questions pop up. I'm always happy to talk about this. So thanks, everyone. Enjoy the rest of the day.